Most valued student, my name is Confident and welcome to the second session of this paper. It's paper 2, June 2018 is for revision, guys, and I just looked at question number 1, and if you are watching this for the first time, it means you have missed out a question. So go back and look at the first question. It will help you. It's under analytical geometry. Remember, guys, it's important for you to subscribe and also ensure the notification bell is turned on. You guys, I expect you to respond. Tell me how you are finding the channel. Is it benefiting? Is it something? Just give me some ideas to say, is it too slow? Is it too fast? Oh, by the way, if it's too slow, unfortunately, leave it like that, because this is for the underdogs. I was once an underdog in maths, and speed, this thing of working this thing too fast, always had me always behind in my mathematics until I found someone who was patient enough with me. So that's why you see I always have a soft spot for guys who take their time. So I'm working this thing way slowly so that you can understand. So guys, let's go to question number 2. And in question number 2, what does it say? We are looking at 2.1. This is trigonometry. Says in the figure below, the coordinates of point P, K3 are given with P or X is equal to alpha. You can see P O X P O. X. I think they wanted to put somehow kind of an X there, you know. But you can see the angle alpha, and the length OP is 5 units, which they did not indicate, but it's very important for you to indicate there. This is 5 units. So they're saying now, these are common questions, very important questions. Determine the value of K. So the moment they do that, these are always important. So what they are saying, guys, is you are given a shape like this. Given a shape like this. So in this, you need to know K is always representing x-axis and 3 represent the y-axis. So in here, this is your y, this is your x, and you know the Pythagoras because this is 90 degrees. So what do you say? In the Pythagoras theorem, it says the longest side, which is 5 squared, is equal to sum of the short sides, the square of the sum of the squares of the other 2 sides, x squared, like that. But if you want to make it easier, you can start by that x. You can actually find x squared to say x squared is equal to 5 squared minus y squared. Why? Because I must take y to the other side. So my x squared, which is k in this case, you see x is representing k. Remember this. And then y is representing 3. So y is equal to 3 here. So I've got k squared is equal to 5 squared minus my y in bracket, always put in brackets, minus 3 squared, always put in brackets. So k squared is equal to, then the calculator here obviously will come in handy. Avoid this thing of you trying to work this out mentally. So it's 5 squared minus 3 squared is equal to what? 16. So I've got 16 here. So how do you find k? You square root both sides, remember? So let me say here, square root of k squared is equal to square root of 16. But remember, when you say square root, you say plus or minus. Very important, because you're going to get 2 answers and one of them is correct. So this is k squared. So k is equal to, now if you come here and look at this diagram, remember we're looking at k, you can see that k is on the negative axis, you know. So hence here, square root of 16 is what? It's 4. It's plus or minus 4, but you're not going to say plus 4. K is equal to negative 4. You can't take the positive. The positive one is the one that is on the other side here. That's where you'll have another one, which is positive, okay? So that is that. So you have that part. The question was determine the value of k, and then 2, determine the value of 10 alpha. So you come here, you need to know 3 things. Remember, you need to know first, I'll say sine alpha, cos alpha, tan alpha in terms of x, y, and r. Sine alpha is equal to y over r. This you need to know. Cos x of r, and then tan is y over x. These you need to know in terms of the x, y, and r, given that. So if they say find tan alpha, they want me to find that. That's why it's 1 mark. You can just state it. It comes from what? From SOHCAHTOA, but you can state it. So tan alpha, 1 mark. So I come here and say it's y. So tan alpha is equal to my y. In this case, I'm back to the diagram here. Remember, here k is my x, and then 3 is my y. So it's y, which is what? 3 over my k, but my k is -4. So you can like that, say tan alpha is simple -3 over 4. Leave it like that. It's correct. That's why it was 1 mark. And then cos 90 plus alpha. There we go. Cos, this is something else. Cos 90 plus alpha. Remember, 90 plus. Oh, by the way, something that I'm doing, which, you know, they say do as you preach. I forgot something. For those of you who have been always following me on trig, I always tell you of the cast diagram to say, do not work trig without the cast diagram, because it is your go-to place. Now, cast diagram, remember how it goes. It says what? All students take chemistry. So you've got all students take chemistry. Then which is 0, this is 90, this is 180, this is 270, and this is 360. Now, where is 90 plus? So this is 90 plus theta. It's in quadrant number 1, 2, 3, and 4. So what is the reduction rule of here? 90 plus is a cofunction. So here, when you talk about 90 plus, it's also 180 minus theta, but we're looking at 90 plus a cofunction. And what is cos? Cos is negative. Remember, all students take chemistry. Cos is -c, negative. So now, since it's a cofunction, cos becomes sine. So this becomes what? Sine alpha. But now you are going to write it as sine alpha with a negative, because cos is negative in the second quadrant. This is happening in quadrant number 2. I think that, which is equal to, now alpha, what is sine alpha? We're here now, which is equal to negative, sine alpha is y over r, which is equal to negative, what is my y? You come back again, there it is here, y is 3, -3 over, and what is r? Remember, they told you OP, which is r, is 5 in this case. That's your r there, which is 5. So that is it, -3 over 5. Let's next one, find alpha. Many ways of doing that in order to find alpha, but the first one there, tan alpha, it can actually help you. What was tan alpha? You can take it from here to say here tan alpha. Therefore, alpha is arctan 3 over -4. 3 over -4. It can just give you the answer there. So if you say shift arctan 3 over -4, let's see what it gives in this case. So shift arctan 3 over -4, and then it will give me what? So that is my what? In this case, yes. Remember, I'm looking at alpha. Now, okay, let me pause again, come back, let's come back. When there is a negative, I was supposed to find the ref angle. So I'm not supposed to use that negative. Let me find the ref angle. So here, to say alpha, first start with the ref angle. A ref angle is arctan that. So now, what is the ref angle? Do that to find now 10, remove the negative sign. First find the ref angle, so remove the negative sign. Say shift arc 10, ignore the negative sign, is 3 over 4. Are you with me, guys? 3 over 4 is 36,869. I think it's 87. Round off there to 2 decimal places, 36,87. So ref angle there is 36,87 degrees. And I told you with the reference angle, what you do is then you say alpha is equal to 180 minus the reference angle, which is 36,89 degrees. Then you will get now the actual angle. You can see that it's obtuse there. It's 180. It's not acute, minus 36,89. You see that? Then it gives us 143,11. I think that degree. So that's very important. That was our alpha here. You can see that it's obtuse, 143,11. The one that you are getting is an angle that is on the opposite side. So you've got this line, and that angle that we got that was negative is the angle that is below that angle there. That's the one that is 36, blah blah blah. So that's what we're getting there. All right, guys, is it making sense to you? I hope so. So there we go. Let's remove that. Let's go 2.2. Given that A and B are complementary angles, and what does the word complementary means? These angles A plus B is equal to what? 90 degrees. That's what they're saying. And cos 7 cos A minus 3 is equal to 0. Determine without the use of a calculator the value of this 7 cos B minus 3 tan A. So again, what they are trying to say to you here is this. Now, if we're saying 7 cos A minus 3 is equal to 0, now you have to make cos A the subject. So 7 cos A is equal to negative 3, jump the sign, is 3. Then divide by 7 on both sides so that you can cancel out that 7. So you've got cos A is equal to 3 over 7. Pause a bit there. Now pause a bit. I'm going to sketch this thing for you here to say, okay, now I'm given cos A like this. I'm gonna sketch it for you like that to say this is my Y, this is my X, and I have got a line like this. All right, and that particular line, when you go down and when you come like this, now you come back to say, remember what is cos? We just erased that part here, which was giving those trig ratios in terms of x, y, and r. I said cos theta was equal to what? X over r. Sine theta, these you must know, y over r. Tan theta is equal to y over x. Remember this. So now cos, you can see cos there, 3 represent the x, 7 represent the r. Are you seeing that? So which means if I can come here, this x here is my what? Is my 3, because it's along the x-axis, and the 7 is there. Now I need to find the y, which I can find using the what? Using the Pythagoras theorem. Now what is the Pythagoras theorem saying? Because it's 90 degrees. So y is equal to square root of, I'm just going far ahead there, it's 7 squared minus 3 squared. You can work it out slowly whereby you say y squared, x squared plus y squared is called r squared, then transpose, then square root at the end. I'm just doing it like that, but don't forget it's plus or minus. So let's do this. Let me take it a little bit not too fast here, just to say if I was using Pythagoras, it's y squared is equal to r squared minus what? Minus x squared. So y squared, what is r squared? It's 7 squared, x squared is 3 squared. You see this, what I'm saying? So you square root here, you square root there, but you say what? Plus or minus. So y is equal to plus or minus what? So let's do that and see what it gives us. So it will be square root of 7 squared minus 3 squared. Remember what I'm looking for? I'm looking for y is 2 root 10. So y is plus or minus 2 square root of 10. But you ask yourself, is y positive or negative? Look at this side. This is y on top, so it's positive. So the answer there is the positive. Y is 2 root 10. So there, the answer I'm going to have is 2 root 10, the positive one. Are you getting that? When they say complementary, now look at this. When they say complementary, if this is my A, that becomes my B, because already I've got 90 degrees, meaning A plus B gives me the 90. So now, what does it mean? They say to me, you are given 7 cos B. You need to determine without the use of a calculator the value of 7 cos B minus 310A. So now, you say, we know A, remember, cos A, we had got 3 over 7. Now, if you are saying here, looking at this cos B, now what is cos B? Now, cos B, meaning we are now looking at that as my B. Remember, now we can actually, let me just show you a few things that is always common here. If I give you, for example, 2, 3 here, I just want to see how it's like. I just wanted something simpler for you, like this. Let me say I have a diagram like this, just a quick one. I just want to show you something quick that will always sometimes assist you. If I've got 5 with Pythagoras theorem, this is 4, this is 3, and then I've got this angle theta. I just want to show you something. If you say, according to SOHCAHTOA, let's use SOHCAHTOA here. This is remember SOHCAHTOA, Toya. Now I want to use cos and, for example, cos. If we say cos theta, you know that is adjacent over hypotenuse. Now, according to this diagram, adjacent is 4 here, which is 4 over hypotenuse is 5. Right. Now, I think the best one would be 10 theta. 10 theta is equal to what? Opposite over adjacent. That's the best one. Now, my opposite here is what? Is 3 over 4. That's the one I want to use. Is 3 over 4. Now, let's say for argument's sake, I want us to find now this angle, which is alpha. So if I say to you now, 10 alpha is equal to, now 10 alpha, remember it's opposite. So all of a sudden, this is no longer opposite. Now it's adjacent. So it's 4. My opposite side now is that one, which is 4 over what? Adjacent is 3. So I want you to compare the two. Initially, I had 10 theta, which is 3 over 4. Let me write it here. 10 theta is equal to 3 over 4. Look at the two, theta and alpha. If this was my A and this was my B, and remember, when I'm writing it in terms of X, Y, and R, remember, 10 what? 10 theta in terms of X, Y, and R is Y over X. So you'll see that this was supposed to be, originally, this is Y and this is X. I think that. But now look at the change. X is 4. It has interchanged. Now this, it has moved from its X, Y became Y, X. Do you see the interchange? Because X now, this is X, this is Y, this is still X. So initially, if you start comparing, X was 3, now it's 4. So XY became YX. Are you seeing that? So it means here the coordinates also interchange. If you are given now same thing here, cos B, now cos B here, what was, you remember what is cos? Cos, the normal cos what? Cos A, right here down there. If cos A was equal to 3/7. See that? Now what about cos B? Cos B now is the other one, is the y now, which is this was x over r. Now in terms of cos B now, it's not going to be x, it will be the y part over r. You interchange. Are you seeing that? Or you can use your normal trig here to say, I've got a triangle like this. I'm going to draw the triangle also here. You can use your normal trig here to say, you have a triangle like this here. I'm just going to pull out this same triangle. You have a triangle that is like this, that is like this, and that is like this. In this triangle, you have got that as your B, what can I call? This is my B, my A, no, yes, my A, B, C. So now if I say to you, what is cos B? Now that angle B is adjacent. See, this is 90 degrees. So cos B is, this is my adjacent. You see that? Which is BC over hypotenuse, which is what? Which is AB. Now my BC, as I said, is now represented by my Y. You see that? Which is 2√10/7. Do you see that? That's the part that I have here on cos B. What about tan A? Tan A is not a problem because it is coming from this part here. And you know what is tan? We said tan is from the original. Tan A is y over x of the original, which is equal to y is what we got as 2√10, and x is what is 3 from the original. So it's 2√10/3. So now if they say here 7 cos B minus 3 tan A, so if I write that and say 7 cos B minus 3 tan A is equal to 7. Now cos B, I write that, which is 2√10/7 minus 3. Then I write that for tan A, which is 2√10/3. I saying that. So that's what I'm writing there. And then you cancel out that. You cancel out that. So the answer is what? Is it giving me a 0? It's 2√10 minus 2√10. It's giving me a 0 actually. Is it correct? So it's 7 cos B. So 7 multiply that, which is 2√10 minus 3 tan A. I hope that's fine. It looks, yeah, according to the calculation, that looks correct. Now that is that. Now look at the next one, guys. Question 2.3. This also very important, interesting questions. This one, 2.3. It mustn't make you struggle, but as I said, I'm just moving a bit faster, but at the same time being sensitive to a few things. Look at this. Simplify without the use of a calculator. So what do you do? Let me write it down here. They are saying sine 210 dot cos 790 dot 10 minus 330 degrees all over what? All over sine 160. 5 marks. And they'll say simplify without a calculator. Guess what? That's the first thing I do. I want to use the calculator, because from there I can be able to tell what is the answer. Why are you saying I mustn't use the calculator? What are you trying to hide? So let's do it. So we use the calculator, sine 210, just to get an idea what is it that it will simplify to. Cos. Then you work towards the answer, guys. So it's not like they're gonna catch you typing this on the calculator and they're gonna disqualify you. It's not like that. They just want to see that there is a proof you never used the calculator when you're arriving at your answer. Okay, but use it now to see what this thing becomes. All right, there we go, equal to negative 0.2886. So this becomes negative 0.2886 something. So let's work towards this thing. All right, now first things first, always they give you things that are intentional. Now let's start by, again, quick part, my cast diagram comes handy. All 0, 90, 180, 270 and 360 with all students take chemistry. And then here is 90 minus theta is 90 plus theta, or 180 minus theta, 180 plus theta, 360 minus theta. Very important information. Quick one, we are done. Now look at the first one. What do we given? We are given sine 210. What will it simplify to? Which quadrant is this? 210 is in the third quadrant, so it's sine 180 plus what number must I add 180 to get 210? Separate 210 minus 180. That's how you get the number. So don't scratch your head now, just separate those two numbers. Say 210, the bigger one, from 180, the smaller one. It will give you the number is 30. So it's 210, you see, plus 30 degrees. Now what is sine? 10 is only positive there, which means sine is negative, so it's minus sine what? 30 degrees. See, that's that. Cos, next one, 790 degrees. You ask yourself, how many 360, because the complete revolution, remember, is 360. How many 360 can I subtract from 720? So you start by saying, 790 minus 360 is a complete revolution. You're in the first point again. Say that again, minus 360. You see, it's 70. So what you can do, you can actually do this, and then you say equal to cos 360 plus what? It was what? It was 360. Subtract 360 there. It was 790 minus 360. Subtract there is 430 plus 430, which is equal to, nothing changes on the sign because it's a complete revolution, which is cos. So let it fall away, which is equal to cos. This is equal to cos 430, which is equal to cos 430. So now we are saying, what is cos 430? Again, from 360, which is equal to, it was 70, I think. It was cos 360 plus 70. Let me just cross check that, just to ensure it is the same. Say 360 plus 70, it gave me 430. Yes. So again, if you are adding 360, it means a complete revolution. This is simple cos 70 degrees. You see, underlined, meaning I have reached. You must always try to simplify it to the numbers that is less than 90 degrees. That's the aim. Okay, you need to grab hold of my lesson for that. There, 10 minus 330. 10. These are negative angles. Minus 330 degrees. You come to negative angles. Remember, sine minus theta, negative angle, meaning you are in the fourth quadrant. And cos is positive, sine is negative, 10 is negative. So meaning all of them are negative. This is minus sine theta, cos negative theta. Cos in the fourth quadrant is positive cos theta, but 10 negative theta is equal to what? Negative 10 theta. So we are first here, first thing is going to get rid of that negative out. It's minus 10 330. That's what you must do first things first, which is equal to, now you are now coming from minus 10 330. What does it simplify to? Is equal to which quadrant is this? 330 is in the fourth quadrant, so it's minus 10 360. That's the reduction rule there. 360 minus theta. So what you subtract to get that? Subtract the 2. The bigger one, always start with it. 360 minus 330 is 30 degrees. So 360 minus 30 degrees. So which is equal to, now what is 10? Again, in the fourth quadrant is negative. So you've got minus 1030. Do you see what is going to happen there? Which is equal to negative, and the negative will affect each other to become tan 30, guys. Okay, so far so good. We've done that. The last one is sine 160. Let's do the last one. Sine 160 is equal to which quadrant? 160 is in the second quadrant, and sine is positive, which is sine 180. The reduction rule there is 180 minus, avoid the 90 wherever possible, is 180 minus. So it's 180 minus what? Subtract 180 and 60. So 180 minus 160 is what? Is 20. And sine is positive, which is sine 20 degrees. So done. Then you bring all this together. You come here and say this, I'll take it like this. So where there is sine to 10, I write what? Negative sine 30. So this is same as saying where there is that, I write that, because that's what it simplifies, and so on. So it's negative sine 30 times where there is 790 is cos 70. So times cos 70 times where there is 10 minus 330, I write 1030 there. These are special angles. Now you see that it's very good now. And then over sine 160 is sine 20. So it's over what? Sine 20. Alright. Okay, so now it's a matter of you simplifying a few things here. Now you can actually, they say don't use a calculator. Remember what they said? They said without use of a calculator, but it's allowed now to say you know the special angles. Whenever there are special angles, you are allowed. For example, you take a calculator and you're allowed to punch sine 30 because it's expected that you know that it's a special angle. So you say sine 30 equal to, you say 1 over 2. Let's do tan 30 again so that we don't come back to this. Tan 30 again is root 3 over 3. That's where they are going to catch you if ever you use the calculator. Look at this. Root 3 over 3 is actually, you must know the original of it. It's 1 over root 3. See? That's root 3 over 3. So you need to know to instead write 1 over root 3. So it's negative 1 over 2 times cos 70 times 1 over root 3. See? All over sine 20. Now, something interesting here. When you are faced with this, always look at these things. They always give you intentionally. See? Look at this part, these two. 70 plus 20, 70 plus 20 gives you 90, meaning there is a co-function part. Meaning what? Sine 20 is equal to, or cos 70, whatever you want to do, sine 20 is equal to, which quadrant is this one? First quadrant, remember. And in the first quadrant is 90 minus. So I'm going to say sine 20 is sine 90 minus what? 90 minus 70. Now it's a co-function. What is sine 90 minus 70? It's cos 70. So sine 20 is equal to cos 70. So where there is sine 20, I can put cos 70 now. and then I'll continue. You can just do the calculator, check it. You know, it's the same thing. Sine 20 is equal to cos 70. You know, so you can just test it here and say sine 20 equal to, say the answer 0.3420. Cos 70 equal to 0.3420. It's the same. So here I have now to say, which is equal to negative 1 over 2 times cos 70 times 1 over root 3 all over, now it's cos 70, so that goes. See that? And the final answer is equal to negative 1 over 2, because that is a 1, times 1 over root 3, which is equal to negative 1 over 2 root 3. That's the answer they expected. It's not the calculator version. If you use the calculator, let me show you what the answer was going to be. So you'll see, if I say negative 1 over 2 square root 3, you'll see what it will do. See, it rationalizes, which is negative root 3 over 6. But let's press ST, which is minus 0.2886, like if I used it, but in bracket minus 0.2886. I'm putting this with caution. Let's check the original. Remember, we did put this in the calculator before we started. There it is, minus 0.2886. So it's correct. It's correct. The answer though is not that. This is the answer. No calculator, remember. Alright, guys. Making sense? I hope so. But yeah, here we go. Now let's look at the other parts. Now I just want to erase this and look at a few things here also that are coming in, just to erase whatever is not necessary. Look at this. The next question here, what does it say? It says I need to simplify, and whatever I need to simplify is what? Prove that, or I'm proving. So that's that. I need to prove that sine x minus sine x cos x all over cos x minus 1 plus sine squared x. Prove that this will be tan x. It's 4 marks. Okay. Now, a few things first. What do I notice? What do you recognize? What are the things that you must see? Because you need to see something, you know. Something must guide you. Something must kickstart your mind to say, where is this thing heading? Because without that, it will be difficult for you. Look at this. First thing that comes in my mind, I'm seeing a sign, I'm seeing a sign. The moment I'm seeing sine x, I can factorize. So which means I'll start with the left hand side better. So you say left hand side, then you write it, sine x, you write it again, because you're starting from the left hand side, sine x cos x over cos x minus 1 plus sine squared x. See that? Equal to, remember we started with the left hand side. I said, you see sine is common there, you can factorize it and say sine x. Sine x into sine x is 1 minus sine x into sine x cos x. You are left with cos x. See, if I open the bracket, this times this, I get sine x. This times this, it's sine x cos x. You see that? So that over. Now something must happen at the bottom. What is it? What is it at the bottom? What is it at the bottom? It's up to you how you want to do it. But now the key one, the key thing, let me show you. The key thing is here. Let me open this is the key thing, and you need to recognize that. Remember, sine squared x plus cos squared x, this is equal to 1. Remember that. So we can actually make sine squared this for the subject there. What is it? Sine squared x is equal to 1 minus cos squared x. I'm saying that where there is sine squared x, so we can literally come and say here, where there is sine squared here, we can say it's 1 minus cos squared x. You see that? So what will I have? then I will have something like this: cos x minus 1 plus 1 minus cos squared x. See that I'm having? Why? Because I want to get rid of this minus 1 plus 1. I'm saying that. Then I have equal to sine x 1 minus cos x over cos x minus cos squared x. See, again at the bottom, look, cos and cos is appearing twice, meaning what? Let me factorize also, which is equal to sine x 1 minus cos x over, at the bottom, cos is common, so cos x. Now cos x into cos x is 1 minus cos x into cos squared. 1 will remain, cos squared means there are 2. Look at this, very simple, guys. This goes, that goes. So what do I have? I now have sine x, not that, I've got sine x. Now what is sine over cos? Is equal to what? 10x. And they said what? Prove that this thing is equal to what? 10x. Then you continue and say, which is equal to what? Is equal to the right hand side. Proven. Done. It's not bad, not much difficult, but yeah, that's it, guys. And then look at the other parts. Let's look at the other parts, which you are being asked. This one is 6 marks. I see it's a 6 marks question. I hope I'm not, though I know I'm speeding up a bit just to avoid this lesson dragging into one of the longest lessons. Sorry about that. Now prove that, okay, 2.5, we're in 2.5 now. What says, given that theta is an element of minus 360 to 90, that determine the value of theta if, then you're given this. Again, let's look at this. You are given that sine 2 theta is equal to cos theta plus 30 degrees. So there are many ways I could have approached this, but I'll approach it from a grade 11 concept, because grade 11 there are some formulas you still don't have. So I'm going to approach it from this side first. Look at this. Convert this using cofunction. Remember, cofunction, what does it say? Cofunction says, if I say here, okay, let theta plus 30 degrees be equal to alpha. So now look at this. If I say cos alpha is equal to, remember, cofunction says what? It's sine 90 minus alpha. That's what the cofunction says. Cos alpha is sine 90 minus alpha. So I can use that here, but don't forget, what is my alpha? My alpha is what? Theta plus 30. So here I'll say sine 2 theta is equal to cos what? I said theta plus this is equal to cos alpha. So sine 2 theta is equal to, now cos alpha becomes sine 90 minus alpha. Sine 2 theta, guys, is equal to sine 90 minus, but my alpha is actually theta plus 30, so minus theta plus 30. Whenever you put two things like this, you put another bracket, and there are now 4 brackets, 2 brackets there. So sine 90 minus theta, then the negative also becomes minus 30. See this? Then this becomes sine 2 theta. Are you with me? When you see sine, you can drop the sign, so that you've got 2 theta is equal to 90 minus 30. It's 60 minus theta. You see that? But now there comes the tricky part. That's the tricky part that students always miss, and they get stranded there. So look at this now. The moment you drop the sign, you say 2 theta is equal to 60 minus theta, then you put plus k 360, then you say or 2 theta is equal to 60 minus theta. Actually, that's not that. Look at this. Where is sign positive? I erased my cast diagram. Let's go back to cast diagram. There is my cast, and where is sign positive? All students take chemistry. Sign is positive there and there. So the first one is 90 minus theta, which is what we captured. This one. This is in the first quadrant. And then the other one is what? 180 minus theta. See, so here we also write that second one, which is 180 minus what we wrote. Are you getting that? So that's what we're going to write. So we're going to write here 2 theta is equal to, remember it was 60 minus theta plus k, 360, but now it's 180. Let me use this pen. It's 180 minus, now you've got your minus theta bracket, 60 minus theta plus k, 360. Please. So you are looking at this one is in the first quadrant here. Take it as your theta. Even here you're taking this as your theta. Okay, but I look at this more detailed, guys. Check my videos, time. So here I've got here what? 2 theta. Take theta to the other side, it will become plus theta, you see, is equal to 60 plus k, 360 there, 3 theta, because it's theta plus theta, 1 plus 1, 2 plus 1, which is equal to 60 plus k, 360. Then you divide by what? By 3, because this is 3 theta. You divide each one by 3, don't forget that. Then you are going to say theta there is equal to 60 divided by 3, it's 20, plus k, 3 there is 1, 2 plus k, 120. See that? Or you work it from the other end. 2 theta is equal to 180. That negative will open and it will open, making positive theta there. It's minus 60 plus theta plus k, 360. Now there is a condition I forgot, and you'll be penalized if you forgot it. If you forget it, don't forget, after writing this, you must state k is an element of real numbers. Very important condition. Don't forget that. Alright, very important. So I've got 2 theta. Now the positive theta coming there becomes minus theta. Is 180 minus 60, it's 120 plus k, 360. See this? So 2 theta minus theta, 1 minus 2 minus 1 is theta. This 1 is equal to 120 degrees plus k, 360. These are the general solutions. General. Now what you need to do, they said, is between minus 360 and 90. Let me write that. They are saying theta is an element of negative 360 up to 90. So now they want us to find the values. The question is, given that this determines the value of theta, value, it looks like it's 1. So what you do, you put values there. K, say let k, remember k is an element of z, meaning k is equal to plus or minus 1, plus or minus 2. See that k is actually starting from 0. It's 0 plus or minus 1. You start from 0. So when k is 0, when you put 0 here, theta is equal to what? That's the first one, 20 degrees. And when k is 0 here, this goes just like there. See that what I mean? So when that becomes 0, theta is equal to what? 120 degrees. See that? You do the same thing when k is 1. So it's 20 plus 1 times 20 plus 1 times, do this, use a calculator there. You say when k is 1 is 20 plus 1 times 120. See whether you've seen the range is 140, but it's outside this range. So try minus 1. Say minus. So I've got minus 100. It means minus 100 is another one. Let's try negative 2. So minus 100. Minus 220 is another one. Let's try 3. Minus 100 minus 340 is also another one. Let's try 220, 100, 220, 340. Let's try 4. It's outside. So it was theta is equal to 100 minus 100 minus 220 minus 340 degrees. Let's look at the question again. What did they say here? Determine the value of theta if given that theta is an element of that. Yes, this means the condition. You do it also on this side to say with the calculator. You are saying, remember we said when theta is 0 is 120. Now you try this 120. If you say plus, it will be wrong. So just say minus 1 times 360 is 240. I see 240 there is working. 240 is fine. 240. Let's do minus 2. We're gonna test this. Minus 2 is out of it, so 240 is another one here. So it's 240 as negative. So that's 1, 2, 3, 4, 5. I hope this is not out of range, but this is this. Now we can test the answer there. You know what you do? You put a theta there, and it must balance left hand side, right hand side. Let's start with 240, for example. Negative 240 was the answer. Theta was equal to minus 240. So I just balance it both sides. It must work for me. Let's start there. Sine 2 times negative 240 is equal to negative root 3 over 2. You saw that? 2 times that. Let's do that negative 240 on the other side. So we must get that answer. Cos what? Negative 240 plus 30. It must give me that answer. Negative what? Negative root 3 over 2. It's working. Alright. Let's try the other one. Let's try, we got all the answers, but I'm not going to prove all of them. You can test some of them. Let's try 20. Let's try 20 here. Remember, left hand side, right hand side. So sine 2 times 20. 2 theta is 2 times 20, 0.6427. Alright, 2 times 2 is 0.6427. Remember, cos is 20 plus 30. Remember, it's 20, 0.6427. Say it's working. You can test all these answers left and right, left and right. It must work for you. So that's it, guys. That's it, guys. And as I said, question 2 goes with question 3. So let us look at question 3 here. Question 3, what does it say? It's mainly a few things here. 14 marks. Just gonna be a bit quicker here, but your calculator mainly plays the part. Says the functions f(x) is equal to that and gx are given. Use answer sheet A and sketch graphs of f and g on the same set of x's for the interval minus 90 and 180. So let's look at this. They gave us some sketch, I guess. So they say we must use this. Alright, so to sketch that, so if I can bring it closer, maybe just to say this comes near that, and then I bring it close. So what we are given is we're given this, and then we have to sketch this. So if I bring my calculator, the calculator, by the way, is the one that is going to work for you. So this is what you do with your calculator. Some of your calculators actually are good because it's a ZA plus, this is an ES plus. It can only plot one graph. Yours can do 2 graphs. So I'm just going to do one at a time. Mod You say number 3 table fx, you start with the first one cos. Now it says 2, then x, you say alpha x, close there, equal to, start from where? They said I must start from negative 90. And then where do I end? They say I must end in 108. See what I'm doing? And then step, always use 15 because it covers 30 and 45. So these are important numbers that you need to use for you to sketch. So in a way you can come up with a table. Let me do a table here like this. It helps to come up with a kind of such a thing. A table always comes handy. I just want to have all those 3 in. Remember I said you can actually have all of them like this. Same graph. These are table of values, but you don't need to have these, trust me. When you are using your calculator properly, you can actually get all these answers. Now look at this. We have got what? F, and we have got, actually we start with x first because it's the x values. X, we have F, and we have G. Now let's look at this. So we can see that start with x from minus 90. Remember, it's minus 90. Now we are moving in what? In 15s, you see. So you have minus 90. Let me write the ones that I'll be needing. Minus 90 minus 1, negative 60, it's 0, and I'm not going to take 75 because it's a funny number there. So I'm going to write the ones that are whole numbers, you see. All these numbers that are simpler for me, they're the ones I'm looking for. Don't look for the ones with 0,866 and stuff. Look for the simplified numbers. See that? So now, let me take them from the top. Let's start from the negative there. So 90 is minus 1, remember? 60 is minus 0,5. 90 is minus 1, negative 60, negative 0.5. Bring it back. We do the same thing. 45 is 0, 30 is negative, and negative 45 is 0, negative 30 is 0,5. So negative 45 is 0, negative 30 is 0,5. Okay, as I said, we are looking for something simpler. Jump that. 0 is 1 and 30 is 0,5. So 0 is 1, 30 is 0,5. See? And we move on. What do we have? 45 is 0, 60 is negative 0,5. So 45 is 0, 60 is negative 0,5. And then go down. So 75 is out, 90 is minus 1. And then 120 is negative 0,5. 90 is negative 1, 120, negative 0,5. Okay, just continuing. That way they were enough. 135 0, 150 0,5. So let me continue. So 135 0, 150 0,5. We continue here and say 135 is 0, 35, 150 is 0,5. Just dividing and continuing that part. And then 180 is what? Is 1. So 180, it gave me a 1. So it's still the same thing. It's just like I'm extending. Picture this thing being extended this direction, you know, whereby I've got 135, 150, 180. That's what is happening there, which is 135 0, 0,5 and 1. So let's extend it like that. I think it's much better like this. Okay, so guys, you see, I'm gonna plot this, but the calculator is the one that is gonna do that. Now let's do the next one. This one is what? g of x is sine that. So what you do is, again, table 3, then you've got f of x is equal to sine bracket alpha, which is alpha x plus 45. See that? Equal to, they say start from what? Negative 90. Are you with me? Equal to, you are ending in 180. Equal to, step 15 is the best. 15 is the best, right? Simplified ones. Negative 75, there it is. Negative 0,5. Negative 45, 0. So negative 75, negative 0,5. Unfortunately, it's not there. Negative 75. I will have here negative 0,5. That's where they did that intentionally. So negative 75, negative 0,5. Negative 45 is 0. Negative 15 is 0,5. Negative 45 is 0. Negative 15 is somewhere there. And in negative 15 also they have a positive 0,5. And then it will continue to say 45 is 1 and 105 is 0,5. 45 it's 1, 105 it's 0,5, it's there. And then I think you wrap it up by what? 135 is 0, 165 is 0,5. 135 is 0, 135 is 0, 165 is 0,5. So that is that. With this, you can plot this graph now. And then they did mention you plotting the graph. They say here, you need to plot that. But now to plot this graph, you need to be careful now. Look at the way I'm going to do the axis here. If I mark these like this, see, they've given you already a hint. Say, how do you mark them? Is it fine to say 30, 60, 30, 60, 90? If I move from here to be 30, this will be 60, this will be 90, 90, 120, 150. Yeah, I think it will work. So this is 30, this is 60. See how I'm marking? 90, 120, 150 and 180. You know why? Because in here it's 15, 45, what? 75, 105, what? 135, 165. You understand? So in backwards here you've got what? 30, 60 and 90. But don't forget, it's the negative version. Now you come back to the values of y. Look at the values. The biggest value of y, it's either is -1 or +1. You see that? You don't have anything further than that, -1 or 1. So you can come here literally and say this is 1 4 squares and this is -1, which means this is 0,5 and then there it's 0,5, the positive one. Then you start to input the values to say the first one, the f, -90 -1. You start with the first one. -90 is what? Is -1. So -90 -1, there is the part. So let me make it bigger. Alright, -90 is -1, -60 -0,5, -60 -0,5. We go there. -45, 0. Sorry, -45, 0. I'm here. That's where is my -45. Okay. And then -30, 0,5. negative 30, I'm up here at 0,5, and then in 0 I've got 1. 0 I've got 1. See, you need to get comfortable with this. 30 is 0,5. 30 is 0,5. 45 is 0, similar to the other side. 60 is negative 0,5. See, it's just a repetition there. 90 is minus 1. And 120 is negative 0,5. 120 is negative 0,5. And then 135 is 0. 135 is 0. 150 is 0,5 and 180 is 1. 150 is 0,5 and 180 is a 1 there. So you can see the shape here, what you are having. Actually, let me use a smaller one now. See that? Yes. So this is what? This is the graph of F. Now you move on to the same one. Now the graph of G. Negative 75 is negative 0,5. So you look for negative 75, which is here. Negative 0,5. I'll use a star now. There we go. And then negative 45 is 0. We're now in the second graph. Negative 45 is 0. There is a star there. 30, okay, sorry, it's not that, it's negative 15 is 0,5. Negative 15, negative 15, negative 15 is 0,5 there. And then 45, 1. I've got 45, it will go to 1. So, okay, I'm trying to see. Okay, let's do that. It's fine. 45 is 1. 105 is 0,5. 105 is 0,5. And I think the last one, okay, 135 is 0, which is also happening there. And 165 is 0,5. 165 is what? It is 0,5 there. So now I'm trying to see how this thing is happening. Does negative 75, negative 45, and then from there it was 15. So it's important to see okay, it's a bit funny the way I'm saying it. I'm trying to see this, whether it will be like this, but there is a 1 there. Okay, let me just check again and look at my numbers again. I have 45 is 1, 45, it's a 1, and then I've got minus 15 is 0,5. I think that's where the error is. Minus 15 is 0,5. It's supposed to be here, not there, not there. It was here, you see. I'm gonna erase that part. This is not there. Now it's much better. because that's the one that was giving me an issue there. Now if I'm to draw on a different pen, I will have something. Okay, I think there is another error there. Let me check my calculator again on 165. 165 is negative 0.5. You see that? So this one is also an error here. It must be below. Is negative. 165 is negative 0.5. So now it does make sense, because this thing is meant to make sense. Alright, it was meant to be actually on that side like this. So it's more like a curve. Let me try to see if I can redo this curve here. So I erased this part and I erased that part, and we say this one was here, supposed to be a curve. Oops. Supposed to be a curve like what? Try to come with a curve like that. Okay, so far so good. And then this, you call it G. You see how it's like. Then they say they answer. You have to answer questions then. Simple one, right? Use the graph to write down the range of f. Range of f. Now they say use the graph. Now if we are looking for the range of f, what they are saying is look at f and then you rule here to say where does it start from. Range means the y values, and what is that is the minimum, and this is the maximum. So you can see that the range of f, that distance is from what to what. Look at that. It's from 1 to minus 1. Do you see that? So how do you write that answer? The range of f. So we are saying f is an element of positive. It's 1 to negative 1. See how you answer that part. Period of G. Now period, to calculate period is actually, period there is 360 over B, and in this case G there is 1. That B there is the 1 there, so the period there is 360. So that becomes a 1. So the period is simple 360. The number of x values for which f of x is equal to g of x. Now look at this. It says what? The number of x values. The number, not the x values. The number. How many times is f of x equal to g of x? Meaning, remember, where is f of x equal to g of x? Where they cross each other. So you look at this graph and say, where do they cross each other? They cross each other. This is number 1. This is number 2. And that is number 3. So there are 3 times. The answer there. Say 3 times. So the answer for that is what? 3 times. And then determine for which value or values of x, where x is an element from 0 to 180, will cos 2x times sin 3x less than 0. Now they're saying you take the graph of f, multiply with the graph of g, you must get something less than or equal to 0, meaning it must be negative. Either they are saying x an element of 0 to 180. So I come from 0 is here, this point, up to 180 is that point. Where I multiply these two graphs, when I multiply them, I will get a negative. So how do you work out the? For you to work out this, you look at the graph. One must be positive, one must be negative. And for you to get that, look at this line. Here, all of them are positive, all of them are positive. It's fine, but from here, there is a change. From here, you see, one graph is on top, positive is above, or the other graph is below. That's where you start to get negative, going this direction. Why? This graph is positive, this is negative. A positive times a negative, I'll get a negative, meaning a positive times a negative is equal to less than 0. Negative means it's less than 0. So you see, I'm getting there, it's still a positive, and it's still a negative at the bottom, negative, positive at the top. So it's still the same until here. That's where that thing changes. From here, oh, still continuing. Deities, let me see what I'm having here. Until, okay, interesting. The graph until where? Until there. Because this graph was supposed to continue like this. So that is where. So here you look at it, it's from here, positive. Now this is positive, this is negative, still positive, negative, positive, negative. Are you seeing that? So let me look at the question here. What is it? Says determine for which values of x, where x is an element of 0 to this, will that and that be less than 0. So here, what are the values of x? So we are starting from minus. You see, we are starting from what? We are starting from 45, because this is 45. I think that up to 180. So how do you write that answer? You say 45 is less than or equal to x, x is less than or equal to 180 degrees. These are the values of x. It was tempting to say it will end here, but it's not ending there on 135 because there is still the other parts there. And then what's the question? 3.4. Okay, last one. Determine the equation of the graph of h which represent the graph of g shifting up 1 unit and 30 degrees to the right. So we go to the graph of what? Of g. Let me write the graph of g. Remember, g is sine x plus 45 degrees. Let's write that so that you can see the transformation. G of x is equal to sine x plus 45 degrees. So now let's shift it up 1 unit. If you shift it up 1 unit, so you're saying g of x is equal to sine x plus 45. Now you say plus 1. 1 unit up means add plus 1. That's what it means. That's the first transformation there. I'll call it number 1. Number 2, then they say 30 degrees to the right. Now when you're moving to the right, you subtract. When you're moving to the left, you subtract inside the x-axis. So g of x, remember to the right, it will be x minus 30. You don't add. So it will be sine. Now where there is x, you say x minus 30 plus 45 and then plus 1. So you're going to get sine x minus 30 plus 45 is plus 15 plus 1. Now this g x minus 30, they say you must call it what? You must call it h. So that's the h of x they are saying. So the h of x there is equal to sine x plus 15 plus 1. Yes guys, I know it's tiring, I know it's heavy, I know you're tired, but don't read this at once. Don't study this video at once. Do it in pockets, you know. What you do, every 24 minutes take a break. Come back again, 24 minutes, take a break. You know, your mind can only absorb up to so much. So don't try to absorb a lot. You'll be just wasting time. It is me who's trying to give you at a go so that you can prepare for your exams. I hope this is very beneficial to you. Join me again when I go for the last session, which is Euclidean geometry. Thank you.